All right. Good afternoon, everyone.
We all have that class, so I'll see on Monday. Oh, I'm sorry.
Good. That's okay. I don't want to interrupt anything. It might be important, you know, I'm talking about. So, good afternoon. We are on the last stretch. So file IO is the last topic we're going to cover, and hopefully, as you heard me say many, many times last week, hopefully what you will see is that it's not that different than what we've kind of been doing the entire semester. Just as a side note, the final, let's go back to Canvas really quickly. I'll post an announcement later with the information for the final, the password and stuff, but it'll be just like the midterm. There'll be a multiple choice part, and there'll be a coding part on Vocarium. There is the date. It'll be on May 3rd. And just like the final, it will be available all day long. It will be comprehensive. It kind of has to be comprehensive, right? You can't really write a program if you don't understand what variables are, which is one of the first things we learned. So it's inherently comprehensive. And it will include what we've covered this week and last week. So it will include structs and file IO, but since we literally just broached the topic, it'll be at a very cursory level for this and struct. So very basic. Can you make one? Can you set the value to the variable? So nothing extravagant, just very basic stuff. With that being said, let us get on with file IO. So we're going to cover a couple of things. We are going to cover saving data. So I'm sure many of us have used a computer program where you maybe have to save your work into a file, or maybe load something from a file before. And we're going to learn how to do that at a very basic level today, just with text files. So how can we write a C program that can save things into or read things from a text file? And we're going to do it with a special type of a variable called a file pointer. A file pointer isn't that different than a regular pointer. All right, so basically it's a variable that points to a memory address of the file. So when you're writing to the file, I may have mentioned this before. We'll just quickly talk about the basics of how a computer works, right? So you have files on a hard drive, and some of those files are going to be computer programs. Those programs aren't run from your hard drive. Before they can run, they have to be loaded into memory. Same thing for files. So any files that you save onto your hard drive exist in memory first, and then they have an operation. Usually it's called some kind of flush or something, where it'll take it from your memory and store it onto your hard drive. It doesn't always happen immediately. So when you're working with files, if you're making a new file or reading a new file, the first thing you're going to go to is that piece of memory. So we're going to have a pointer for that. So file pointer, my file. It's a special kind of a pointer that's made specifically for files, interacting with files. So file pointer. But aside from that, the word file, and you do need, I think you need to import the standard library to be able to use this data type. So it's a custom data type, but it is basically a pointer. So file in all caps and the pointer, and then whatever you want to call that variable name. Aside from that, it's kind of just like a pointer. You need to give it some memory. You do it with the fopen function we'll talk about in a moment. You need to free it when you're done. You do it with the fclose, file close function. So pretty intuitive naming conventions, I think. And one pointer, one variable can only point to one file, right? So if you have a regular pointer, you can only point to one variable. It's no different. So file pointer, and here we are. So suppose we were to call it my file, that's my variable name. Then we would need to call the fopen function. This is kind of like malloc for us, for this type of pointer. And what you need to give it is the name of the file, potentially the location. So if you're running this program, c.exe, if you're running it inside the folder that has the file you want to open, you can just give it the file name. That's typically not going to be the case. So if it's not true, if the file is not exactly in the same folder as the executable file, you have to give it the whole path of the file. C, my users, R Sardinus, my documents, here, and then here's the file name. So that's what this means right here. You either give it the name if you're in the same folder, or you give it the entire path to the file so it knows how to get there. And this last piece here, so two parameters, parameter number one, and they're both strings. Parameter number one, where's the file? Parameter number two, what do you have permission to do with the file when you open it? So you have to tell it what you want to be able to do with that file. Now note, comment in red down here, and many people will do this. Many people do this. This is a common mistake. That's maybe a better way to put it. This is a common mistake people make on the exams, which is the most important place to make a mistake in this class, right? So very commonly people will make a mistake here. Once you use that file name right here as a parameter to this function, you never use this again, period. This is the last time you'll ever type the file name in your program. From this point forward, you use the variable. You don't ever use the file name again. So please remember that. Again, that is a very common mistake that I see students make quite often. Use the file name as a parameter to this function, and then you never use it again. Let's talk a little bit about permission. So that second parameter is pretty important because once you open the file, it'll make some space in memory for you. This determines how you're allowed to interact with that file. There are several permissions here. There are more that can be included. I only care about the top three. So I do expect you to be familiar with the top three permissions, R, W, and A. And I feel like they're pretty intuitive. Read, write, append. So read, you have permission to open the file and look at its contents, and that's it. You can't change anything. Write, you have permission to open the file and write stuff in it. Append is similar to write. The difference in the two is if a file already exists, the write permission will erase everything in it and start over at the beginning. The append permission will start at the very end. Whatever the last character was written to the file, it'll start immediately after that. So again, I think it's pretty intuitive how they behave as well. So read, open the file. You can only read to it. You can't change its contents. If it doesn't exist, you get a problem. You get an error. Write, it will open the file. If it doesn't exist, it'll make it for you. If there's something in it, if it already exists, it'll erase it. And then you can start putting stuff in the file. And then A, append, open the file. If it doesn't exist, it'll make it for you, just like write. If it does exist, it'll start at the end and you can start writing stuff in the file. So here is an example of opening two files with different permissions. So in the first example here, you can see I've got a variable that I called in file or input file and another variable called out file. So this, I'm going to read from this one and I'm going to write to this one. And you can see here for this variable, I'm going to call fopen. Here's the file name. I only want permission to read. This one, fopen, here's the file name. I only want permission to write. So exercise number one, we're going to kind of work through this as we go along. It should be fairly straightforward. If you have your computers with you, go ahead and do what I just did. Open a file, write a program that will open the following two files, one to read and one to write. So I believe you will need the standard library to access the the file data type, the file pointer data type. Let's do we'll do that so we can print things. Standard library, so we can use a file pointer. And then we'll just write some stuff. All right, so help me out. How do I make a file pointer variable? That's right, just like a regular pointer, but your data type is going to be file in all capital letters. It is in all capital letters, it does matter. So file, we can actually just make two of these, F1 and F2. Now, if I want to open a file with F1, I want to point it to a file. I want to open a file and point to that space in memory. What function would I use to do that? Fopen. And what are the two parameters? I have to give it two parameters. The file name, so we'll just call it, we'll say file1. And what's the second one? Your permission, that's right. So we want to open one for reading and one for writing. If I want to open this and I want permission to look at the file, look at the contents of the file, but not change it, what permission would I give it? R, very good. And we can do the same thing for file 2, except different file name, one for file. And what permission should we give file 2 if we want to be able to write something in it? W, very good. Now, if we compile this and run it, we should see there actually wasn't an issue here. It returned an error code, but we didn't see it because I didn't save it. What's the problem with what I did just here? So if you look on the left, if you look at my file explorer, you'll see because I used this W permission, sure enough, it made that file for me. There's nothing in it right now, but it did make it. What's the problem with what I have right here? No, they have to be strings. They're supposed to be strings. It has to do with how I open this. What do we say happens if you open a file for reading and the file's not there? That's right. And actually, if we were to, so this does return something. If we printed what it returned, I think it should be some negative number that represents an error code. Two has file pointer. Oh, it's supposed to return something. Let's try to run it and see what happens. 0, if we did this for both of these. Does this return 0 too? There you go. So it returns something different. So 0 for null. So we see this returned a file pointer. Let's look at the error message again, because I wasn't supposed to try to print that. This returned a file pointer. I chose to print it as an integer. And you can interpret variables however you want to. I chose to print it as an integer, and null, the code for null is just zeros. So hence, therefore, it printed 0. I think a better way to do it would be to do it as an if statement. So if, for example, null is going to be 0. So if that thing is true, so if it actually makes a file, then we can say, you know, yay, it opened. And the other one, we can kind of just see that it had that it worked successfully because it made the file, it actually made the file. But this one, this is probably a better way, a more appropriate way to do it. So you can see, sure enough, nothing was created because that file didn't exist. It didn't make the file pointer for me. So what I needed to do first was go over here and make a new text file. We'll call it file, oops. File1.txt. Now, if I go through and run this, we can see that it actually does make a pointer to that file because something was created this time. Oops. All right, very good. So now we know how to create file pointers, create file pointer variables, and let's say initialize them using the fopen method. How do we actually use them though? How do we rewrite them? So we're going to use, these aren't the only two functions you can use. There are other functions. We are going to look at these two functions because they are very similar to functions we've been using the entire semester. So the very first one is fscanf. So fscanf will scan a file for some input and save it into a variable. It works just like scanf does. So we should all know how to use scanf already, right? Scanf, you give it some format specifier for a data type that you're looking for, and then you give it an address of a variable to save that into. It behaves exactly the same way with files. The only difference is there's an F in front of it, and the first parameter should be your file variable. That's it. That's the only difference. Except for that, it behaves exactly like scanf does. So, and for writing into a file, similarly, we're going to use fprintf. So just like printf, it works exactly the same way, and it prints everything exactly the same way. The only difference is there's an F in front, and the first parameter now has to be the file name you want to write into. So let's try this exercise here. Let's take those two file pointers that we just created. Let's put a couple of numbers in that first file, and let's try to read them, sum them up, and write the sum into the second file. All right, so keep in mind, this should be very straightforward. fscanf works just like it has, just like scanf. It behaves exactly the same way. Just put an F in front, and the first thing should be your file pointer variable. And printf also works exactly the same way. Just put an F in front and use your file pointer variable. So let's try to do that. Try to, so we'll go over here, for example, in file one, I'll put 1, 2, 3, 4. We'll just put a couple variables, 9, 10. So there I've got a couple variables now. Try to read a couple of them, sum up the first 3, right? And then just take the sum, instead of printing it on the screen, print it in your file. Let's try the first piece here. How could I read a couple of numbers from this file? So let's say we need to make them first, right? Now, I could make multiple variables, or I could do what? What else could I do if I know I'm going to store multiple things? I could make an array. So why don't we just do this? Let's just say num array. And for now, we'll just do 3. I know how big I want it to be. And how would I scan 3 numbers from the file? So if I didn't have a file, if I was just using scanf, how would I scan 3 numbers from the keyboard and save them into these 3 array elements? I can make a loop, okay? So let's do this too. So for I equals 0, I less than 3, I plus plus. So that's our standard loop. And what is it going to do? So what would we do normally? We would say scanf. What am I scanning in? Some number, right? So how do I say that? Yep, %d. And then the variable I want to save it in. So we can use array or pointer syntax. If we use pointer syntax, it's going to be num array plus I, right? And let's just see if it worked. We'll actually print them out while we're reading it. So print out. All right, so we'll test it as we go. So instead of writing the whole thing at once, let's test it as we go. What did I do? Oh. And let's run it. And oh, I have to type something in. 1, 2, 3. Very good. So scanf works. Now, how do I take this and go from scanf to fscanf? How do I transition to using the file instead of the keyboard input? And F1 has my stuff. That's where my stuff is. That's it. Very good. Let's try it out and see what happens. We'll compile it and run it now. And sure enough, that's exactly what it does. It behaves exactly like that. So with fscanf, every time you call it, now keep this in mind, until you close the file, your fscanf remembers where it's pointing. So every time you call fscanf, it'll scan until it reads that thing in, and then it'll stop right there. So the first time I called it, it actually scanned this number and stopped. And then when I called it again, it scanned the next number and stopped. And when I called it again, it scanned the next number and it stopped. I haven't closed the file yet. I could keep calling it if I wanted to. If I called it 1, 2, 3, 4, 5, 6, 7 more times, it would scan the rest of these numbers. So just keep that in mind. And printf works the same way. It starts printing characters. Every time you give a printf command, it'll print characters up to that byte in the file. And the next time you give it, it'll just pick up where it left off until you close the file. Once you close it, it starts over. Very good. So we know how to scan it from a file. Now, how could we print? We need to sum these up. Let's do this. We need another variable. We need to sum these up and print it. So for now, if we were just trying to sum up an array, we could do another loop, right? I equals 0, I less than 3, I plus plus. And if we wanted to just use printf to print the result, well, first we'd have to sum them up. Let's do this. Right, we need to start somewhere. So sum plus equals some array I. Now we've got our sum, and at the end we can do sum divided by 3. Oh, actually, what is there potentially an issue here? So I'm going to add all my numbers together, and then I'm going to divide it by 3 to get my average. Is there an issue with what I'm doing here? Or you think it's going to be okay? You think it's going to run just fine? That's right, because I'm using a whole number and I'm dividing by 3, there's dividing by whatever, there's always the potential that my result could be a floating point number. So sum probably shouldn't be a whole number, right? Let's go ahead and make it a double. And here, we'll just do this divided by 3.0. And now we can print that. So print. So this is how we could print a double, right? So we're going to read it in. We'll print it out, and sure enough, 6 divided by 3 is 2. Great. It was able to print it. We were able to print it on the screen. Now, how do we transition from this, where I'm printing it on the screen, to using fprintf, where I'm printing it in my file? What's the difference? Printing it on the screen or printing it in my file? How do I do that? That's what we want to do. I want to print it in this file right here. That's it. Very good. So it's exactly like printf. Just make your first parameter your file variable, put an F in front of it. And now if we compile it and run, you'll see nothing gets printed this time, right? It just did these that we put in here to actually, let's get rid of that because we don't need to test it now. We know it works. And we'll run it. And if we look in the file, there we go. We have the number 2. We printed a space before and a space after. So it printed, it works just like printf does. It printed that new line character, then it printed the number 2, and then it printed the new line character again. And just so we can see, if I were to print anything else in here, we can print anything we want in that file. Let's say, just so we can see it, it always, until you close the file, it picks up where you left off last. We could do something like this. Hi. I wrote something else in here. And it's going to print exactly what I tell it to. So what do we think this is going to look like when I put it in there? Like, how is it going to be 3 separate lines? How do we think this is going to look? No, right? Because I'm not printing the new lines. Very good. If we were to compile it and run it, it's going to print exactly like I told it to. And sure enough, right, new line to new line, and then I had 2 print statements back to back. It just picks up right where it left off until I close it. As soon as you close the file, that starts over. Finally, it is a type of a pointer. So it's very similar to a pointer. So just like a pointer, you have to free it when you're done. You have to release that memory that you've reserved when you're done, that you've allocated. And for files, you just use the file close function and give it the name of your file pointer variable. So remember, we never use the file name again once we open it. The only time you ever use the file name is when you open it. From that point forward, you always use the file pointer variable name. So to wrap it up, we just need to go through here and close this. Now, once the program goes away, it's going to close by default, but it's a good practice to get in. If you have a longer program, right, you do just like with pointers, you can have heap, you can have memory heap exceptions from running out of memory if you forget to do this and you make too many files. Or you can make some really big files, all that's going to be in memory. And then if you never close it and you keep opening files and keep doing things, you could potentially run out of memory, right? So we always want to get into the practice. It's a good practice to be in of closing files when we're done, just like we would free pointers when we're done. So some additional comments that we've already mentioned, just a refresher. Once you open the file, you always use the file variable name, the file pointer variable name, okay? Never use the file name again. Once you open it, you only use it in the fopen function. You have to be careful when you open a file, when you call the fopen function, you give it the correct permission, because that's all you'll ever be able to do with that file. Now, some of the other permissions we didn't look at, they have combinations where you can actually read and write to a file, but typically it's better to do just one or the other. That's a little dangerous to be trying to do both to one file. And just like a pointer, you have to free a file when you're done. And just like any other variable in general, a file pointer can only point to one file at a time. You can reuse the file pointer if you want to. So if we had, let's go back to this. Let's suppose we called F1 and we opened file 1. And then we use the same variable name to open file 2. You could do that if you wanted to, but then you would have lost your reference to this. That would still be in memory somewhere, but you wouldn't have a pointer to it, and you would only have a pointer to that second file. So you could do it, but it's not advisable. Recap. This should be very easy, right? That's the moral of the story. We already know how to use scanf. We already know how to use printf. This should be easy stuff for us. We already know exactly how to do it. We talked about declaring file pointer variables, just like any other pointer, except capital file, F-I-L-E, and we need the standard library. We talked about opening files. We spent some time talking about permissions, right, as the second parameter to it. And we also looked at an example of reading, writing to files, and we talked about closing files. Do you all have any questions for me? All right, that's for the final, that's about what you can expect. I do expect you to know how to do this. This very simple exercise. Can you open a file? And I'll give you code examples, ask you questions about it. Can you open a file correctly? Can you use fopen correctly? Do you know about file permissions? Can you read or write to a file? Like very basic stuff. That's it, nothing fancy. All right, if you all don't have any questions, we'll do an exercise on Wednesday. We'll do an in-class exercise. I don't think it's a Vocarium exercise, just an in-class non-graded exercise to get some practice with this. Otherwise, have a good evening, everyone. I'll see you on Wednesday.